Network monitoring tools process over 2.5 zettabytes of data annually. That's enough information to fill 100 billion iPhones. And today we're exploring how these invisible systems keep our digital world from falling into chaos.
That's such a mind-blowing statistic, and what's even more fascinating is how these tools have evolved from simple traffic counters into sophisticated systems that can predict network problems before they happen.
I know, here's another amazing statistic. NetFlow processes about 50,000 data points per second on a typical enterprise network, which is remarkably similar to how air traffic control systems track thousands of flights simultaneously.
And what makes it even more powerful is how it can spot patterns in all that traffic. For instance, NetFlow recently helped one major bank detect a data breach that was stealing customer information at just 1 kilobyte per second. So slow it was almost invisible.
Oh, wow. That reminds me of something that happened at my previous workplace. Our network suddenly slowed to a crawl and everyone was getting frustrated. The IT team used NetFlow to discover that one department was accidentally running massive backup operations to our remote data center during peak hours.
You know what's interesting about that? According to recent studies, about 73% of network slowdowns are caused by these kinds of internal misconfigurations rather than external attacks, and the average cost of network degradation and downtime is around $5,600 per minute for large enterprises.
That really highlights why these monitoring tools are so crucial. But NetFlow isn't working alone, right? There's this whole ecosystem of monitoring tools: remote monitoring, or RMON, simple network monitoring protocol, or SNMP, and system logging protocol, or SYSLOG. They're like different specialists in a hospital, each with their own expertise.
That's a perfect analogy.
Welcome to Technically You, where we turn complex networking into surprisingly bingeable audio. And today's episode is like bugging a secret conversation. We're talking about how networks report on themselves using tools like NetFlow, RMON, SNPP, and SYSLOG.
These are the tools that give IT teams visibility, like giving glasses to a blindfolded network admin.
Since we touched on it already, let's kick things off with NetFlow, developed by Cisco. It's a network protocol that collects IP traffic information as it enters or exits an interface.
Think of NetFlow like airport security cameras. It doesn't show you every word spoken, but records who's coming and going, when and where they're headed.
It captures flow-based data: IP source destination, ports, protocols, byte counts, and timestamps. No payload, just metadata. The benefits of NetFlow are understand traffic patterns, detect anomalies like DDoS, helps with capacity planning, and can identify top talkers.
NetFlow is used in data centers, at ISPs, and enterprise networks, network operations centers, and security operations centers, basically anywhere deep traffic analytics are needed.
Now, let's talk about SNMP. It's like the universal translator between network devices and management consoles. It lets you monitor and manage routers, switches, servers, printers, anything IP-enabled.
SNMP uses agents installed on devices that respond to queries from a central manager. You can pull device status, interface errors, CPU usage, etc.
There are 3 versions: SNMP v1 with basic features, a simple structure, with clear text passwords, and there's SNMP v2c. It added bulk transfers, but still lacked encryption. Finally, they created SNMP v3. It is secure, supporting authentication and encryption.
Here are the benefits of SNMP: real-time device health checks, automation via alerts called traps. It's scalable for large networks. And SNMO is used in network operations centers, NOCs, third-party managed service providers, and enterprise monitoring solutions.
Now, if SNMP is the sensor, RMON is the data recorder. It's an extension of SNPP that collects traffic statistics directly on the device, so the manager doesn't have to constantly poll. It reduces polling traffic by allowing switches and routers to collect and store their own data. Helpful when dealing with busy or remote locations. There are 2 RMON versions, RMON1, which focuses on layer 1 and 2, Ethernet stats, packet counts, errors, and RMON2, which adds layer 3 and 4, IP conversations, application-level stats.
RMON is used in WAN links, branch offices, or when SNMP polling isn't scalable. And the reason to use RMON is because it reduces SNMP overhead, improves historical visibility, and enables proactive troubleshooting.
Here is a breakdown of the three. NetFlow equals traffic flows. Who's talking to whom and how much? SNMP equals device status. Is this router okay? RMON equals historic traffic analysis and trending, especially layer 2 to 4.
Think of SNMP as checking vitals, RMON as reading a health journal, and NetFlow as reviewing security camera footage.
And last but not least, Syslog. It's the messaging system of the network world. Devices use Syslog to send event messages to a central logging server.
You might see alerts like interface down, temperature threshold exceeded, or login failure. Syslogs are used for auditing, security event tracking, and troubleshooting.
Syslog doesn't query devices like SNMP. It waits for the device to report something. It's event-driven.
So in summary, NetFlow is who's using your bandwidth and how. SNMP is how your devices are feeling. RMON is how things have been over time. And Syslog is what just happened.
Together, they provide the eyes, ears, and brain of network monitoring.
Whether you're a network engineer, a student studying for your certs, or just a tech junkie, understanding these tools gives you total visibility.
Subscribe to Technically You and join us every week as we untangle the wires of IT and emerging technologies. Until next time, monitor wisely and stay curious.